announcements. Okay. We are live. We are recording. So I decided to record during this class period today because third period was the first time I looked at the problems. I may not have been my finest teaching. And fourth period, they talk too much. So you are the third class today. I don't have any more. If you don't have yours, you don't have yours. Okay? So, question number 1, I'm hoping should not have been a problem for you. I do get that it's a little confusing. Like down here, did they mean that base? So I think you want to focus on it's the major parts of the building. Okay? Any questions on number 1? Number 2, what you're doing here is you're taking the 2 arcs, adding them together, and dividing by 2, and that's going to give you the measure of the angle. So 120 plus 2x divided by 2 equals 4x. Which means 60 plus x equals 4x. I subtract x from both sides. I get 60 equals 3x. X equals 20. If x equals 20, this angle here is 80, correct?
Yes.
But they didn't ask for that angle there. They asked for AED. It's a little difficult to see, but they're asking for this angle. This angle is a linear pair to the angle that was 4x. The 4x we said is 80, so this one is 100. It does not matter, first of all, on a grid whether you left justify it or right justify it, but remember, this is a paper practice test. Yours would be you just type it into the computer. Okay? This was just a paper practice assessment back from the days we had grids, which I don't know if you guys even ever had a grid because you guys have always been.
It's on the PSAT.
Oh, it's on the PSAT. Okay. Okay. For the next question. Okay. And I'm going to actually try to make my pen a little bit thinner here. Guys, I do not think you can do questions like this without starting to mark stuff up. Okay? So they tell you that this triangle is going to move 4 units to the right and 4 units up. Make sure I did that right. 1, 2, 3, 4. 1, 2, 3, 4. So there's the new S. There's the new T. There's the new R. Whoops. Okay. So I can see that they say they're going to do 2 different sets of reflections. We learned 2 rules about lines being reflected. We learned that if something is reflected over 2 lines that are perpendicular to each other, it's the same as a what? Does anybody remember if they're interested? If they're reflected over what?
Translation.
On a translation.
180 degrees.
180 degree rotation. But if this to this was 180 degree rotation, then it would be orientated differently, right? It would be looking more like that or something when it rotates around, all right? So it's not that. The other type we learned that if you reflected over 2 parallel lines, that was the same as a what?
Translation.
A translation, okay? So right away, that's the one we're looking. What I did when I did this was I looked at the word choices first. First of all, we're talking about lines. No such thing as congruent or similar lines. There's congruent or similar line segments, but not congruent or similar lines. So once that I got that was parallel, looking at the choices. If I reflect over a line, x equals something, and I want to reflect over two parallel lines, my second choice has to also be x is equal to something, correct? So I can't use either of these because I don't have another line here that says x is equal to something. And the same thing with the y's. Do you understand why I'm crossing out the x's and the y's?
Yes.
Okay? I could possibly have an answer, let's just say like x is equal to 4, x is equal to 6, although that's not it in this case. But I need to have both my first choice and my first reflection and my second reflection both being x equal to something. With the choices I'm given, I can't do that. With the two choices here and the two choices here, everything has a slope of -1. So all four of those lines are going to be parallel. I need to figure out which one is the right one. So what I would then do is I would start to try to make some lines here. If I do x, -x plus 5, that line's going to look like that, correct? And then so it's one of those two, correct? And then it's either that, basically, or I think it comes through like that. I'm off slightly there, but that's how it comes through. And I notice that two of the choices are actually touching one of the vertices. So if I reflect this over here, it's going to sit right here, okay? That's going to be too close that then when I reflect it, if I pick this and this, it's going to sit right here, and then I reflect over here, it's going to be all the way up here, right? It's not going to land in the right place. So now I look at this one. If I pick this, it's going to end up like over here, and then I can see it would have to be this one, because if I pick this one and it ends up here, and then I reflect over this, now I'm on the wrong side of that line. The other thing you might notice here, and it just worked out this way, both of these, it was the two lines that went through the vertice that were not the ones I picked, because basically I needed the figure to move more than that allowed it to. I do think this problem is difficult. I don't think you can get it right without actually like drawing out some lines and figuring some stuff out. So when I walk around and I see kids be like, well, Mrs. Falk, I wasn't able to do it, and we got no, you weren't able to do it, sorry, confiscating phones here for the class period, and then there's nothing written, you don't have a triangle there, you don't have any lines drawn, it's very difficult to do this without drawing anything. Does that help with that one? Okay. Next problem. On this one, your default for the standard form of an equation of a circle would be x minus 3 quantity squared plus y plus 4 quantity squared. So that's where they're getting that x minus 3 in absolute value. It's absolute value because basically it could be the center could be 3 to the right, or it's x value 3 either way. Okay, it's also when we do this and you square it, you always get positives in there. When you negative squared is positive, yes.
But if it's the absolute value of it, then why?
It works. Because the default is x minus 3. Because if I wrote this in the standard form of an equation, that's what I would be writing.
But wouldn't in the end, because it's an absolute value?
No, because the standard form of the equation says x minus 3, y plus 4. Okay? Okay? The total distance from x to y to the center is the radius of the circle. So any point on the circle to the center, you're moving an x value and you're moving a y value. And then this is your radius, right? That's Pythagorean theorem, correct? You're making a little right triangle there. The x value in this drawing is the base, length of the base of the triangle, or one leg of the triangle. The y value is one leg of the triangle. The radius is the hypotenuse. It's Pythagorean theorem. What?
But how is it like the Pythagorean theorem? Like a curve instead of like a right
But the distance, you're talking about, you're taking the distance, you're taking the horizontal distance and the vertical distance. You're squaring each of them, right? Those are your two legs. So the horizontal distance squared plus the vertical distance squared equals the radius squared. This is the horizontal distance squared. This is the vertical distance squared. Right? This is the radius squared. That's what it is. It's why it works. Hopefully, given the choices, you would have gotten Pythagorean theorem because it's not really perimeter formula. And quadratic formula has not been an answer all year, has it?
No.
Even when we used quadratics, we did not use the quadratic formula. We either factored or completed the square. And I said to you, I wish that you were not taught the quadratic formula last year. I wish that because you can solve anything that you can't factor with completing the square. If they hadn't taught you the quadratic formula, you'd be better at completing the square. You can't complete the square because you said, oh, I'll just use the quadratic formula. Yes. Yes. Okay. Do we understand this one? Okay. Number 5. You have to actually try each one. Now, the thing that we found, and I wrote it over there on the board, rotating from a center is different than rotating from a point. Okay? So rotating 180 degrees on K is like that. Okay? But when they talk down here about 180 degree clockwise rotation about point E, a lot of kids are thinking that that just went like that. It doesn't, because you're talking about rotating from the point. So you have to think of the rotational symmetry of the figure. Since it's a 5-sided figure, okay, and it has 5 lines of symmetry. It has rotational symmetry of 72 and 144 degrees. It does not have rotational symmetry of 180 from a point. Okay, and that was, we found last period, that was a lot of confusion. That is something that, I didn't test you as much on as maybe I should have. But sometimes I don't want to make your test too difficult.
It's hard because there's no values for the point.
Right, and it's hard because there's not values for the points. Okay, I find these very difficult. But if I reflect across a line EK, it flips up and down. Okay, then I reflect 180 degrees counterclockwise about K. Now I have a triangle, I have a pentagon that looks kind of like that. And then I reflect it across a vertical line. It's back on itself. But that's what's difficult, and we found that E, a lot of people were picking E, but that's your issue. E, you're rotating around point E. It does not have rotational symmetry around that vertex. Does that help a little bit? Yeah.
180, is it negative x, negative y?
Yes, it got erased. That's negative x, negative y. We're going to go through those also tomorrow. I have to erase that obviously for Thursday morning, but that board is kind of like the last minute things, like, the things that when we went through class or going through this and people were like, seemed like across the board wasn't remembered.
So for E, how do you know that it's not like rotational symmetry around a certain point?
Because it says around point E, and E is one of the vertices.
Like you just kind of like.
Because it's not, it's a pentagon, it would have rotational symmetry at what? 72 degrees and 144, because 360 divided by 5 for lines of symmetry is 72.
So basically, whenever you're like not rotating on the symmetry, means rotational symmetry.
Okay? Yes. 72 and 144, sorry. I'm having pen issues. Okay, when you all do really well, then I can go to Mr. Zagari and ask him for money for a new slope for next year. Okay. So does 5 make more sense now? Number 6, Alejandro cut a circle with a circumference C and radius R. And then Alejandro put them together and kind of made a parallelogram. Okay? The height of the parallelogram is not equal to the circle's diameter. It's equal to approximately the radius. That's why it's D. Okay? The area of the parallelogram is not the entire circumference times the radius. This is half the circumference, right? The circumference would be 8 of these. But they're pie-shaped, so the circumference here is, it's half the circumference roughly times the radius. That's not exact, but it's gonna be close, correct? The length of the parallelogram is not equal to the circle's circumference, it's equal to half the circle's circumference. We talked about why the radius of the circle, that one's correct. What they're doing here is they're using TJ's trick. If this is a circle and it makes 8 congruent sectors, 360 divided by 8 is 45. By the way, that would simplify to 1/8. 1/8 times the area, not doing a proportion, times the area, is going to give you the area of one sector, correct? Then if you want the area of the whole thing, you would multiply it by 8. Right? What?
Where you have 1/8 pi squared, there should also be an R.
Oh, there should be an R there, thank you. I'm having a lot of issues today. Sorry, that should be pi. Oh, no. I thought it was going to, pi radius squared. Sorry about that. Okay? You wouldn't really do it this way. You wouldn't really, to find the area of the entire thing, take 1/8 of the area and then multiply by 8. You wouldn't, if you had the entire area, you wouldn't take 1/8 of it and then multiply back. But you could. Do you understand this question? Yeah, if you were to find the area of the parallelogram, it's approximately pi r squared, right? Yeah.
How do you know that the radius, like the height of it is the radius instead of the diameter?
Okay, because look, think about this. I took a circle. That's now divided into 8 pieces, right? From the pointy edge to the end of the circle, that's the radius. Okay? And I actually did this one at home, and I actually was having a hard time with it, and I actually drawed, whatever it is, out the circle.
That makes more sense.
Yes. And then I was able to better do it. Number 7. I don't think this was an issue. They gave you the new E and the new R, and they asked for the transformation, and it was multiple choice, so it was only one choice. You didn't have to worry about were there multiple answers. Number 8. This is where you want to read very carefully. Catherine uses triangle ABC, where DE is parallel to AC, to prove that a line parallel to one side of a triangle divides the other two sides we're proving that is dividing two sides proportionally. We are proving a proportion. Our last statement is probably going to have a proportion in it, right? Okay. Some of you, I know, looking around the room, picked A. And I think you picked A because you saw subtraction property over here. Remember, subtraction property of equality as a reason would then be over here. It would look like after the subtraction. So for instance, and even here you're not even subtracting the same thing. Here you're subtracting BD and here you're subtracting BA unless you've already proved that they're equal. Maybe you've already proved somewhere that BD and BE are equal, so then it would be BA something like that. Do you see how this is it after subtraction? Okay? When you look at, so I looked at the proportions here. You want to prove that it divides a triangle to sides proportionally. BA and BC, those are the entire sides of the triangle, right? And then DA and EC are a part of a side. You want to prove, though, it breaks the sides into the same proportion, meaning you need these two parts, DA and I think it's DB. No. DA, I could see everything at once, it would help. DA to BD, those are the two sides of the triangle, are the same proportion as the two other sides. The two parts of the other side of the triangle. So you're proving part of the side is to part of the side is the same proportion as the other two parts to each other. Okay? If you need to go to the bathroom again, that's fine. You're good? Okay. 9 should not have been an issue for anybody, correct? What did you think it was? Okay. It's making a cylinder knot.
I'm kidding.
No, I think it's good sometimes to keep because then if I ever had an issue where somebody said, well, is so-and-so behaving in class? I'm not saying she's not behaving. I'm not saying she, I mean, honestly, right now we can't get too upset with her. She got you all the ability to have a retest. Yes. What? Yeah. So, I'm still working here. Spit out the gum. So basically what we're doing here, and this is not exact, but our TV is going to be formed using this transformation. Since this transformation is a decimal less than 1, it's getting smaller, correct?
Yep.
So, that's the same as a fraction of its 1/5 the size. So if the smaller side is 1/5 the larger, then 5 of the smaller would equal 1 of the larger, correct?
Yes.
Okay. Now, what they're saying here, okay, is that RV represents the length after the point 2, right? But it doesn't. The length after the point 2 should have been up here if this one were correct. Okay? Number 3, basically, you have RT. And you go to RT prime. And you do that by taking 1/5 of RT, correct? When you take 1/5 of RT, these are now congruent, correct?
Yes.
So by basic multiplication property of equality, if I then multiply this side by something, and I multiply this side by the same thing, they're still equal, right? If I multiply them both by 5, they're still equal once I've applied the scale factor. So that's actually what's being done here. They're just multiplying both sides by radical 10. Remember, you can multiply in any order. Yes.
So the number there, as long as it's the same on both sides, doesn't matter.
Right. Actually, the number there, exactly what you said, as long as it's the same on both sides being multiplied, it's fine. If we had addition or subtraction, we might run into some issues because there's order of operations. So you'd have to determine whether what order the order of operations would be. So for instance, if I did 0.2 radical 10 RT, okay, and then I did -4, then that's okay because I'm multiplying first. If I did radical 10 RT -4,
Ben, turn it off, Ben. Ben, put the phone away.
times 2, that's where I would get into some issues, okay? So this one, just as long as you're multiplying the same side. The problems with D and E, again, you are taking the scale factor and multiplying it by the side that's already smaller. If this was 0.2 RT, then you'd be fine. Over here, simplify this. Radical 34 over radical 34 is 1. They cancel out. TV. If this is 1, then this is just 0.2 times 1. It's the same thing. Okay? Does that make more sense? I think this one to me is so confusing till you realize that the radical 10 or the radical 34 doesn't matter what number I throw there. And guys, it's possible they could give you something like that. So if you get some weird radical signs, I would check to see if that's actually the length of one of the sides. And it might be like, well, wait a minute. It might just be they're saying any number. Okay? Okay, that's the end of the calculator session. Practice session. Now we have the non-calculator practice session. Okay. Now we're going to talk about partitions. The partition formula is over there on the board. Okay? I'm going to, in the other classes, I've used the board over there. I'm going to write a little bit over here, but if you're having troubles reading my writing, it's over there on the board. It's just when you watch the video at home, you don't have that board over there. So, yes?
I think it's driven.
Sure. So my first issue here when I did this was AB to AC, and then they put 2 over 5. So I was like, well, that would be like that. Is that 2 over 5 or 2 over 7? It's actually in this one not, and I want to explain why. Because if you draw this, A, B, C, but they're saying A to B is 2, and A to C is 5. That's why it's 2 over 5. If they said AB to BC, that would mean AB would be 2 and BC would be 5, so the total thing would be 7, but they don't. I want to make sure you understand that part first. Okay? The formula. I'm going to do the Y one because when I did the X one, I messed it up 7 million times. And then I finally noticed, oh, the X coordinates are the same for both points. So the X coordinate of the partition, the point of breakage, is going to be the same as -3. So the partition formula, when we say Y, we mean the Y value of the coordinate of the partition. We're going to start with Y1. We're going to add to that, we have a K value and the distance. Some of you guys would say, well, Mrs. Falk, I just realized that from 6 to -4 is -10. Well, guys, if you do the formula, if you do 6 minus, wait, No, sorry, if I just do it this way. Okay, if I did -4 was y2 minus 6, I get -10. Okay, you follow that? So the distance is -10. I want 2/5 of that. 2 times -10 is -20, divided by 5 is -4. So if I start at 6 and I subtract 4, or I add -4, I get to 2. Do yourselves a favor and memorize the partition formula. Okay? If they gave you where they gave you the one of the coordinates and the midpoint, and not the midpoint, the partition point, and you were finding like the beginning point or the ending point, then you would leave those blank. Following me? You got that? Clear annotations. Okay. Number 12. Are there questions on this one? Because it seemed like everybody got this. Okay. Number 13. The diagonals of a square are shown. One diagonal is shown. Well, the other diagonal is going to bisect, correct? And I think when I figured it out, I just kind of, that's the middle, right? That's the midpoint. And the diagonals in a rhombus are going to intersect and form 90-degree angles. So if this has a slope of up 1 over 2, I'm going to go up 2 over 1. And I can very quickly see that the only point here that's going to be on this line is -1/6. Okay? Because they're congruent and are perpendicular. Okay? Even though bisect each other is correct, this was a fill out one of them. Perpendicular is more exact. Okay? Number 14. You're finding the perimeter. So the length of the sides that are vertical or horizontal, you can count. The other 3 use distance formula. Or you could use Pythagorean theorem, correct? 2 squared plus 3 squared. So 4 plus 9 is 13, and the square root of 13 is whatever that is. On this, I would probably end up using Pythagorean theorem because I think it's a little bit easier, but you can use either. This one was you watched an animation, correct? When we actually looked at this on the computer yesterday, we actually watched an animation. When you take the test, you may have an animation. There is no sound with the animations. You do not need headphones. I have told their testing teachers so that if you're in the middle and somebody suddenly goes, there's a thing playing and I don't have sound. You don't need sound on the Geometry EOC. There is no sound. But somebody's going to do that, and some teacher who doesn't normally deal with geometry is going to freak out and be afraid that the test needs to be invalidated because your sound isn't working. Okay? Number 16. A lot of you left this blank, and I'm not really sure what the problem is. Okay? You have a pile of phosphate there. It is in the shape of the cone. You're going to have a second pile that's going to be equal in volume to this one. So the first thing I'm going to do is find the volume of this pile of phosphate. That's the radius squared times 3.14 times 15.3 divided by 2. I don't remember what the answer is. It's like 9,400. What was, what?
9,456.
That's the volume of your new pile of phosphate. Your formula for volume is for a cone is 1/3, okay, times pi radius squared times the height. If this height is 15.3 and your other height is 3.6, what's 15.3 minus 3.6? What? Okay? So, you'd multiply by 3, right? You divide both sides by 11.7. You divide by pi, radius, square root of the radius. Or you take the square root of it out. Do you understand how we got 55.6?
Somebody cited the volume wrong. Because I got 55.4 and it started with the volume.
What did you have for the volume?
9,270.693.
9,270.
Yeah.
Do you have what you did there for the volume?
Yeah. And I was 24.3.
Okay, hold on a second. 24.3. 24.3.
Times like 1/3. And then.
Wait, but 24.3 times 24.3, right?
Yeah.
Times 3.14. Okay? Times 15.3 divided by 3. I don't know what you did wrong. What did you say? Did you divide by 3 before? What order did you do it in?
I didn't set the right order. I just don't know what happened.
Well, what was your order?
I didn't write it down. I just wrote down like the numbers that I used.
Okay, it sounds to me like, because even when you started repeating it, it sounded like you said something about dividing by 3 before you multiplied by pi or something.
Yeah.
Maybe, yeah. Do it in the right. Because the issue should be, normally it shouldn't make a difference, but because the 3.14 is weird already, already, I would do radius squared times pi times the height and then divide by 3. The order should not matter. It's mattering because of the rounding issues. Okay. Number 17. Okay, you guys need to mark this up. When you read all this and mark it up. DAE is congruent to DAC. Okay? And we had DA. Okay, and they had FDA. This one is congruent to that one. And that's angle, side, angle. If you put DAB to DAF, instead you change the order, instead of DAF to DAB, it would still be considered correct. It says down here. If you put, instead of putting E and F, if you put F and then E, you have the same thing, you just have a different order, it's correct. Do we understand that one? Okay? The population density question, was there any issue here?
I just needed to, like, how you did the percent, how it increased by 5%.
Okay, so hold on. So population of Florida was this, and the land area was this. The population increased by 5.8%. Okay, so you're going to take 18,801, 310, and you're going to multiply it by 1.058. 1, because it's you still have the 100%, and 5.8%, that's a percent. To turn that into a decimal, you move it 2 spaces to the left. So when you get that, that's your new number. Then are you okay?
Yeah.
Okay. Okay, so I'm going to do 18,801, 310. No, what? Oh, this calculator's bad. 18,801, 310 times 1.058 is 19,891,785.98 people. Okay? What is people per square mile? So divide, yes?
Was someone missing a thumb?
Okay. We know that we can't really have that. You got the point. You want to round it to 6, that's fine. It's not going to make a difference, and I don't want to, I have all those numbers in the computer, in the calculator, I mean. Even if they're missing a thumb, they're still alive. Divided by 53625 is 370.94. That rounds to 371. Okay? So how much did it increase per square mile? You could have done two things. You could have found this number, right? And divided. You could have found the population density. Or I think you can just do, that's what I would have done. I would just do the population density of the other number. So 18,801,310 divided by 53,625 is 351 was the population density here. And here it's 371. So all you people who have moved here since 2010, go away because now we're more crowded.
I was here since.
Well, then you get to
More than-
stay.
Yeah, I was here for 5.
Okay. Could you imagine if we decided to build a wall to keep y'all out of Florida from other states?
No. Why don't we just
Good
build,
idea,
like,
Cuba.
a big trench around the Panhandle and then just float off into the Caribbean?
Sounds great. Okay. I got one more problem to do. Shh. Guys, this is trigonometry. You got to do 2 different problems. Okay? These are very bad triangles. But the hypotenuse of each of these right triangles is 56.84. This was a 5.5 degree slant. It went to a 3.99. Okay? The height here is how far you are above the ground when you're standing at the top looking straight down. So as the building got straighter, it went up. The length of the building did not increase, correct?
No.
So I want to find this height, which is actually adjacent to the 5.5 degree angle, correct? So adjacent over hypotenuse is cosine. So I'm going to do cosine of a 5.5 degree angle is adjacent over hypotenuse. So in my scientific calculator, 5.5 cosine times 56.84, and I get 56.58. Okay? Now I'm doing the 3.99 degree angle. So now I'm doing 3.99 cosine times 56.84. And I get 56.70. That is 12 100ths, or 0.12, 12 100ths of a meter that the building got taller. Okay? We follow that?
Yes.
I think that finishes it.
Yes.